Hi guys, it's Annalise, and this is my 25% schematic design for the Capstone 2023. Okay, so my problem is fast fashion and textile waste. Textile waste is a major part of what pollutes our landfills and also what pollutes our air from degrading. 75% of textile waste goes to landfills and 25% of it is recycled. And then another 1% of that recycled plastic or textile is turned back into clothing. 64% of the textile market is synthetic fibers, and then polyester makes up 54% of the whole market, meaning that the bulk of the clothing that is getting thrown out is synthetic, and that also means that it won't degrade. How might we use our PET, which stands for recycled PET plastic, in forms that is not turning it into more clothing so that the new recycled products stay out of the landfill? That was my original how might we question, and I tweaked it just a little bit. Now it's how might we use recycled synthetic fibers to create a durable product that uses a lot of fiber so that the new recycled products stay out of the landfill. Here's the process. So this is the supplies that I'm using for my prototype. I have the resin here, mixing cups, and then trays to pour everything and put everything together. When I shred this fabric, this is 100% polyester. You can kind of see it's literally just like woven pieces of thread. But when I shred it, it turns into this type of fiber, which if you look at it, you can see that it's even more tightly wound up. So I might try to get those more apart, but also I might try it just like this to see how this works. But this is a dress that was donated to Goodwill, and it's a synthetic fiber. And I'm going to use this to test out like ratios of how much fiber versus how much resin, and so on. I'm cutting up the fabric into smaller squares. I've learned that the larger squares don't shred as easily, and then I'm going to the corners and I just grab like both of the threads, so meaning like the ones that go vertically and then the ones that go horizontally. I just grab the corners and then pull them out, and then creates this. Okay, so here we have the different samples, I guess. They're not going to be ready for 48 hours according to the package. But this one has the most resin compared to fiber. I think this one has the least. So this should hopefully just be like a sheet of hardened-ish string, essentially. This one is pretty even on the ratio here. And then this one's like a little bit more than this one, and then a little bit less than the one that has the most. And then this one is the thickest, like in width. This one's gonna be the thinnest. And then these two are almost the same in thickness. Okay, so here are all of them fully cured. This is the least amount of resin to, honestly, I think it's this right now, the most amount of resin. This one is the hardest. It won't really bend that much at all. The this one, since I missed a spot, it still bends, but on the edges it doesn't really bend at all because there's a lot of resin in there. This one bends a decent amount, but not too much, and then this one still bends quite a bit. But I believe that it is the fibers that are making them bendable and pliable.